Well, welcome back again. Today, I want to talk about sinkholes themselves and what we call a sinkhole hazard. That's actually my preferred area of research. I study how caves form, how the water and the rock interact to dissolve the limestone and the dolostone, or what we call carbonate rocks. But really, I got into this interested in why do sinkholes form and why do they form where they form. And if you've been in America in the last few years, you might remember a bunch of Corvettes that fell into a sinkhole underneath the Corvette Museum. There have been cases of somebody whose house fell into the sinkhole, or I believe there was even one unfortunate case in Florida where someone was in their bed in their bedroom when a sinkhole collapsed underneath their bedroom, and that person lost their life. So there's lots of different things, and the first thing I should say, and I'll repeat it later, is I wouldn't worry too much about being swallowed alive in your bed. That makes a lot of sensational news, and that gets many people scared about sinkholes. In our studies in southwest Missouri, here at Missouri State, we've discovered that probably less than 5%, or maybe about 5% of the sinkholes that we see are that kind of collapse sinkhole. Most of the others are very gradual, slow ground sinking over time. So I want to kind of start setting the stage by putting your mind at ease, but I'm going to tell you that I have some slides up on Blackboard that show some very great, very eye-catching collapses. And one that I want to talk about today is one that I studied not long after I moved to Missouri State University. It was a house in a small town near here called Nixa, Missouri, and a gentleman woke up on a Sunday morning, picked up his Sunday paper, sat down in his easy chair to read the sports section or something like that, and he heard the sound of wood kind of creaking and tearing. And I know I hear the wood creak in my house all the time at night when it's really quiet. And on Sunday morning it was fairly quiet, but he thought maybe there had been some wind outside. Again, Missouri is not far from what some people refer to as Tornado Alley. It wasn't a particularly stormy day, but he thought maybe a gust of wind had knocked an old tree in his yard over, and the tree had collapsed on his roof, and he was hearing all the wood of the rafters hit. Well, what he did was he, luckily for him, walked out his front door and looked to the side of his house because it turns out there was a big hole at the end of his driveway. And in fact, his two-car garage had sheared right off the side of the house, had torn off the side of the house, and fallen actually about 75 or 80 feet straight down. So yes, that's the kind of collapse sinkhole that people do get nervous about. And I've spent quite a bit. I've got a journal article where we published some of the possible things that might have triggered this event, beyond just living in an area that is known for sinkholes and caves and known for this karst landscape. So I've put some pictures on Blackboard of what it looked like right from the edge of the sinkhole. If you think about a little whirlpool that might suck water down and take mud and dirt and debris with it, that's exactly what it looked like. In fact, I was fortunate enough that I was called out there by the local community had asked for my help. They knew the university had some experts in this area, and they already had police and fire on site, and so as sometimes people say, lucky me. I was carabinered to the edge of a fire truck ladder, the type of ladder truck that you normally see sitting up, leaning up against a tall building in a fire or a movie where they're rescuing people. And that might reach 6 or 7 stories, 60 or 70 feet in the air. In this case, they just put it flat down on the truck and spun it from where they loaded me onto it out over the center of the sinkhole, because you didn't want to park the truck too close. And that's a warning I'll give everybody. You never want to walk real close to the edge of a sinkhole, and I'll explain later in a little bit why in a little bit. But I've got a couple pictures here that I've put up on Blackboard for you, and you can see it's quite something to look straight down. I was actually even with the rafters of his ceiling on his first floor of his one-story house, and so I knew that I could take off about 10 feet of the height of that first floor and still have about 75 feet of sinkhole before we were hitting bottom. And even then, I never saw the rafters of his garage or any part of his car that was in the garage. And so the hole might have in fact been probably closer to 100 feet deep. And there's lots of little things. One of the reasons I say you never want to be on the edge is often when a sinkhole collapses, it's a void underground that has done what we call stoping. And that is, if you think of a lava lamp where it's kind of a bubble, as an opening occurs underneath the earth, oftentimes the soil near the top of the opening will collapse in little bits and pieces. We've all seen movies where, you know, little rocks are dropping from the ceiling all the time in a cave or something like, or the old mines in the old westerns. And those little rocks and things eventually create a hole. And that hole often has sort of an arch shape at the top because nature likes to make arches. And as those arch shapes kind of block each other, bit by bit, eventually the soil might dry out and continue to fall in. And when it eventually falls in enough that you get a hole at the surface, you'll have sort of curved arches leading up to the hole at the surface. And so if you walk out on the edge, you're right on the edge of really not very much support underneath. It's kind of like one of those old cartoons that I used to see when I was a child of, you know, road runners and coyotes and Bugs Bunny and things like that, where they would always walk on a cliff that really didn't have much support underneath it. And if you put too much weight, you can go through. Well, anyway, I've put some pictures of that hole up on our Blackboard site, but I'll tell you what people always ask me. In fact, what the city asked me and their mayor and their city council when I got there. They asked, why did this happen here? Why under this gentleman's house? How big will it get? Are the other homes nearby at risk? How about the utility lines? Did they cause anything? Are they at risk? There's water lines and gas lines running underground in most parts of the country. There's power lines maybe buried or maybe overhead. There's sewer lines. And what's that going to cost, and how do you fix a hole in the ground like that? Well, I'll try to sort of explain some of those risks, but really what I want to do is tell you, how does this form? Well, I think we've kind of gotten through enough by now that I can say this quickly. Limestone dissolves where water flows. We know that water, especially as it comes through the landscape and the atmosphere, pick up a little bit of carbon dioxide, and so it's not perfectly neutral. It's a little bit of carbonic acid as it gets into the ground, and water with carbonic acid reacts with limestone and dolostone, the carbonate rocks, and bubbles away carbon dioxide back into the atmosphere and dissolves the calcium and the magnesium and some of the other elements that make it a solid rock. And usually that starts by landing on the land surface and finding a crack in the rock where just a little bit of water can puddle up or pool up. And that accentuates itself over what we call geologic time. It may not seem like much if I were to put a limestone, garden stone out in my walkway. That may not ever seem to have much dissolving going on over 8 or 10 or 20 years that I live there. But if I looked at something that has been exposed on the surface of the earth for tens of thousands or hundreds of thousands of years, or even over geologic time, millions of years, one little niche, one little low spot will eventually erode and dissolve more and more and make a much more noticeable crack or fracture. And once the water ponds up there, it's kind of like a clogged toilet in your house. It's still looking for a way to get out. And so it wants to find its way down through the pipes and out. And that's the other part of how limestone dissolves. First, I need usually some sort of vertical impetus, some vertical pressure or force driving things down. And gravity is a nice force that drives it. So the higher up in elevation I am on gravity, the more that water wants to get down to a low spot. I used to tease my students, water is sometimes one of my favorite things because it's as lazy as me. After a long, hard day, it wants to just go lay on the sofa or lay in the gutter. I don't lay in the gutter, but I think you get the picture. Water is always looking for the lowest spot it can get to. That's why it accumulates in valleys and river bottoms and streams and lakes. And ultimately, it goes to the ocean, which are the deepest parts of Earth. You and I have water that lands on our landscape, and it wants to find its way through the rock to the lowest spot it can. So it looks for a vertical crack, but then after the vertical crack, it's still going to look like water coming out of your bathtub or the plumbing in your house for a drain pipe that feeds it on out. That drain pipe is usually layers of rock if they're flatline rocks like around Missouri, or much of Florida or even Kentucky. And often that flatline rock is what I call a mini cave. It may be too small for you and I to get in, but it's forming a cave and eventually will become a big enough cave that we could crawl in or walk in. So when the vertical cracks intersect a flat-lying or relatively flat-lying drain, that gives water a pathway to go from the hilltop down to the valley bottom or down to the side of the hills in the springs. And so what I like to say is sinkholes grow where water flows. And so when I get those two places together, often right where they meet, they'll dissolve a little bit more because water has some unique properties that we've talked about with the chemistry, that it can mix and dissolve more of whatever you've poured in it. And that means that I often find, like some of the pictures I'm putting on Blackboard, that vertical cracks and horizontal cracks often have sort of enlarged areas where they meet and become little caves. And so that's how I form sinkholes, is that once I have a cave that can drain lots of soil out or mud out of there, the crack up top will open up wider and wider and suck in dirt and soil and those sort of things. And so wherever water flows is where sinkholes are growing. And when we look around the Ozarks where we live, we can see lots of examples. Anytime they've cut a highway through the hillside, almost any time you'll see some places where there's what we call pinnacles of rock sticking up, and cutters or grikes, valleys where there's dirt and soil that have washed in what used to be a small fracture and is now a wider gap. And so that's a little bit about the why. I'll put a figure up on Blackboard, which is from our Missouri Geological Survey, and many state surveys have ways to either learn what is a sinkhole or what is karst if you search their websites. And they'll have similar cartoons. But I'll stop there and pick the next bit up in another little segment in a second. All right, so welcome back to the rest of the lecture on sinkholes and what sort of hazards they pose. I was mentioning that I've already got up on Blackboard a couple of pictures of how sinkholes are forming, places where our highway department here in Missouri has cut through a hillside and exposed fractures and cracks that are widening out as they dissolve, and they're connected to relatively level or flat-lying, what we call bedding planes in the rock, layers of the rock that are able to transmit the water out. So I need an abundant supply of water, which we have in the temperate, moderate, humid Midwestern climate here. I need a vertical driving force of gravity and elevation, and I need a horizontal drain. And those three things are the same thing that makes water from your shower drain out the pipes in your house. And unfortunately, that's exactly what it looks like. I have these pipes, if you will, running underground, and I'll have some figures up on Blackboard about some of the ways people have figured those out with dye traces that we've talked about before. And over time, those pipes, if they reach the top of the rocks themselves, can let soil wash in. And sometimes the soil just washes in gradually, and the whole hillside of the whole landscape just sags in the middle as the soil gently washes in. And it settles, just like cereal in a box of cereal might settle if you shake it. And it's never full to the top of the bag when you open the box, is it? And they always say on the back or somewhere in the package, settling may occur during shipping. That if you shake something up that's kind of fluffy and chips individually, you shake it, it usually will settle a little bit lower than it was when you first poured it in there. But also, just like cereal or just like some candies that you cut the corner of a bag off and try to pour them out, if you pour it the right way, sometimes 2 or 3 of those candies or 2 or 3 of those flakes of cereal or clusters will jam in that little hole on the corner of the bag all at the same time. And then what do you have to do? You or I might, poke a finger or a knife up in there to free them up and watch them all pour out again. But when they jam up like that, that's actually a thing that scientists call bridging. They're bridging that little gap by interlocking. If you and I and 2 of our best friends all try to run through a doorway to get out of a building at the same time, we might jam all of our shoulder blades at the same time and kind of block the doorway. And it could become very tough for us to get out. But if one of us stopped and said, "Oh, I'm sorry, I'll back up," and was able to squeeze our shoulders sideways, we might all flow through the doorway again, and so could all the people behind us. That's the concept of whether a sinkhole develops by gradually just sagging the soil on the landscape down into the cave system and the plumbing system, or whether it develops a hole that's bridged at the top, but eventually some stress, either weight on top of it or just the slight shaking of the earth or wind pressure changes, or even sometimes the soil getting too wet and then too dry, it might just collapse. Like I said earlier, I will say this, in Missouri, our studies show that those collapses, and we've studied well over 300 sinkholes, our studies show that those collapses are probably only about 5% or less of the sinkholes. So would I worry if I lived in an area that might have sinkholes that any of you students might be in, that I'm about to fall in a sinkhole, or my house is going to be swallowed up, or I'm going to be swallowed up alive? No, that's a very rare occurrence. If 5% of these happen that way, and how often are you there when they actually happen? If you think about the Corvettes in the Corvette Museum, no one was there when it happened. It just happened to be that, being a museum with valuable automobiles, they had lots of security cameras that ran all night. And so if you just think about the coincidences that must occur, your chances of ever being swallowed alive by a sinkhole are very, very small. Having said that, your chances of being swallowed alive by a sinkhole, if you walk up to the edge of one that has opened up, especially if it has that kind of arched back sides to it, and you walk out on the very thin part of the soil. I've had more than one colleague who has accidentally gone too far and fallen in, and in a couple of cases, pretty significantly injured themselves. Got some pretty good concussions. One friend hit his head and actually put part of his eyesight out that way. So we do caution people. The best way is much like falling through thin ice. You want to get as flat and broad and spread your weight out. If you need to go see, or better yet, in this modern day and age, use a drone or use a camera, or try to get some elevation somewhere a little away from the hole where you can look down and into it. That's a much better way. But that's why we pay attention to these things. They do form, they are hazards. In an area like southwest Missouri, where 60% of the rocks underneath us are this kind of dissolving rock, what we tend to find is that almost anybody's home is at risk of settling and shifting. But before you feel bad for us, or before you feel bad for yourself if you live in an area that has sinkholes, I would note that there's lots of other places in the country where there's a lot of clay in the soil that shrinks and swells. There's places in Alaska where as the ground heats up just from the heat of the floor of your house, you melt permafrost, and so it becomes unstable. There's places in Alaska near the coastlines in the U.S. where just the shaking of the earth from earthquakes and seismic waves can cause what's called liquefaction. And if there's too much seawater or water table right by the coast, and you shake the ground with a lot of water, that too can become liquid and not support a building. So these problems exist lots of places, and we have lots of pictures of them that I'll show you. But really, the other questions that I would ask, and people often ask me, is, can I live next door to a sinkhole? And the short answer I often find is that in many cases, and in the house in Nixa that I studied once, we can discover that the hole might have been where two cracks in the rock met and allowed the soil and the water to wash away. And in between where there's two cracks, where if you think of an X on the ground, the houses on any of the corners in between the X's might have been on what we call pinnacles of rock sticking up, or pillars of solid rock that weren't dissolved away yet because the dissolving and the soil washing was going on where those cracks or fractures are. So oftentimes it's not necessarily that dangerous to be close to one, as long as you're not just walking out to the very edge of very loose soil and seeing how far it will fall in. So you have to think about those kinds of things. That also leads us to another idea. We often think if there's a linear trend, a crack or a fracture in the rock, and there's fractures all through all the rock in America and anywhere in the world, Earth's natural plate tectonics means that most rocks have stress and cracks and fractures at some point or another. And so if that vertical crack might be a pathway for water and it's just looking for where the horizontal drain is, then we like to look along vertical cracks. Can I find a trend, or can there be a series of sinkholes in a row? And in some places it's very easy to line sinkholes up right down a crack or a trend that we know often from a caver, exists in the ceiling of a cave or in the rocks. So that's one thing to look at. What other things do we look for? When we looked at the house in Nixa that fell in, we realized that the gentleman had had a septic tank. When that house was originally built in the 1960s, it was a very rural, small town, and so most of the houses were on septic tanks. And what's a septic tank do? It takes the water from your plumbing and distributes it through drainage lines, and it appears that perhaps some of the drainage lines might have funneled the water into faster draining soil compared to slower draining soil. Well, the faster draining soil might have been draining faster because there was a small cave passage or drain underneath it, or a crack nearby that the water was getting into. The homeowner didn't cause that sinkhole, but that could have told us that there might have been uneven draining and there might have been some soil that was draining quicker than others, which might be a nice hint that there's something to look for. Other things were the homeowner had chopped down some trees, some very large pine trees, and anyone who's ever worked with trees or any other plants will know that when a plant dies, the roots shrivel up a little bit. So if you chop down some large trees and leave the roots in place, they actually shriveled a little bit, and they made a pathway where the root hole, where a healthy root had been pushing the soil out and growing bigger as the tree grew bigger. When the tree was cut down, the root kind of decayed, the wood kind of decayed, and that left sort of a little filmy pathway, because water just slides along things very well. Anyone who's ever watched a car wash or watched the rain start to slide down the windshield of your car knows that water likes to stick to other substances and do that. Other things, the gentleman in the house in Nixa discovered some drainage issues. He had some of his gutters and downspouts that were all funneling water into places that they didn't really seem to drain out of, but the water would actually go somewhere else. There were dry spots and wet spots in his yard, as I understood it. And so, not that that would make any of us look funny at it, but now in hindsight, you could look and say some of his soil drained much faster than others in his yard, and some of his gutters and downspouts did that, and that might have been a hint that there was a crack or a joint or a fracture underground that was letting the water drip away. Farm ponds that don't hold water, or that hold water only after a really big rain and then seep out the bottom quietly, are a pretty good indication. In many parts of the world, stream valleys that look like their normal valley that should have a stream in it and only has the stream when it's raining and then it goes dry, that's another good indication that maybe there's sinkholes or those kinds of things nearby. And so where those things all came together on this gentleman's house, where the septic drain field was, where the gutters and downspouts drained into the fast draining soil, and where the old tree roots were all very close to the corner of his garage, and it was his garage that fell in. So we suspect that each of those might have been not a factor in causing it, but a signal that now that we know a little bit more, maybe we could look for. And we start to look for this in other places. And in fact, we see this in a lot of places. I'll put some other pictures up of smaller sinkholes in front yards that still did the same thing. They're where the top of the rock is high in some places and low in the middle with sort of a trough or a crack or a joint that's full of dirt. And things just sort of fall in and work their way around there. So that's what we watch out for. That also means sinkholes are often, not always, often in lower spots or towards the low spots because they're trying to feed water there. But it turns out in our studies, at least in Missouri, we're seeing a fair number up on hilltops because they have a lot of there's a lot of driving momentum to get that high gravity from a high spot down to the low spots. So different things you can think about. Sinkholes grow where water flows. There is sort of a perfect storm needed, if you will. You need a certain kind of drainage. You need a certain amount of humidity. You need the right kind of rock. You need the right kind of what we call geologic structure, cracks and fractures. Maybe those are even linear. You need maybe some depth or base level that the water table's flowing along. And there might even be other cycles or connections. There might need to be second sets of cracks or joints that provide lots of ways for the water to get deeper into the earth. Those are the things we look for when we're trying to understand how big a hazard sinkholes are. But I would encourage you to think they are a hazard, but they're no more than most other natural hazards, and they're probably not going to swallow you alive. But they will make parts of your house sink or settle just as many other parts of the nation have. I'll stop there, and I know that we'll be taking questions over the emails through the semester, so through the course. So thanks again for joining me today.